Hello, hello, hello. I've returned. I apologize. I believe this was 15 minutes late. If I remember correctly. 15-20 minutes late. I apologize about that. Had some Wi-Fi troubles getting in there, but we're on there now. Yeah, you may need to change there's the subscribe thing and the drop down. You may need to change it to all notifications. If you haven't done that, that might make the response a little faster. But here we are, very close to the orbit insertion. We are T-minus 30 minutes from lunar orbit insertion. Are you ready? We're going to unfreeze the time in 5, 4, 3, 2, 1. We're live. Look at that, is absolutely amazing. That view is really good. I send this to ein Freund. There, I sent to ein Freund a photo of the moon. And we are 30 minutes away, so naturally, we need to get started. No, the sun is in the exact right position. You'll see it later. Alright, when we come out facing towards the Earth, yeah? Because the Earth is not over, like the Earth is over here, so this side is gonna be, you'll see. Yeah, you'll see. 75 55 34 49, proceed. 27762. No, we must reload with minus 28926 minus 04253 minus 00069. Proceed. And here we change to the lunar insertion. Looks good. Proceed. All right, let's start our timer. Proceed. 00. Enter. Delta V set to 2917.8. 2917.8. Okay. Non-essentials to main B. And we get the DAP load worked out. 21102 01111. All is good. And the burn attitude. Good. Now, lunar orbit insertion procedures for comms has S-band aux to down voice backup and PCM bitrate low. Good. AMSO. AMSO. Apollo mission simulator for orbiter. Looks interesting. Not as simulated as NASP is, but it still looks pretty cool. And it looks like you can even do the EVAs, maybe. Which would be pretty cool. I mean the spacecraft EVAs out in space instead of just on the moon. Yeah, that's pretty cool. I still think I like NASP better. More simulated, more interactivity with the cockpit. But I might give that one a check out. That's just stellar. I mean, well, literally, but you know what I mean. That looks absolutely tremendous. Hold on. It's getting a little bit toasty, so I think I'm going to closing the window. You'll have to excuse me in my, I just got done with German mode, so my English mode is not kicked in, so my English is not so good yet. Oh, thank you for joining, James. I was just wondering where you're at. You know what? Here, take a look outside. Take a look at that. I am going to go put the vacuum away because I realized I forgot to earlier. Yeah, could you at least EVA out in space? Because you can't do that in NASP. But it looks like you could in there. It would be really cool, Red. I wouldn't actually... Because how it seems like is... It seems like it's mostly like you're just along for the ride, sort of an experience, as opposed to a simulation. But it would be really cool for when I do my cinematic videos that I have planned in the future, to actually take some of the stuff that they have there and put it in, splice it into NASP, so it's looking really cool, right? Because in NASP we can't do those EVAs that they did in Apollo 7 or the Simbay EVAs or any of that, so it would be really cool to be able to splice that stuff in there, you know? Just a thought. Yeah. A hand with little gloves on it. That would be cool. Yes, that would be cool. Unfortunately, I'm not sure how to change the mouse cursor. I'm not sure how to change the mouse cursor. But that would be kind of funny. But yeah, I mean, isn't this just looking... It's looking really good, you know? Let me put you guys down for a split second. Yeah, I'll take a look at AMSO. If you can do that kind of stuff, I'm gonna absolutely splice in footage. What are we at? 16 minutes, 30 seconds. Enough time to use the restroom. I'll be right back. Okay, we're back. Let's see here. Almost down to the wire. Very awesome. Sextant star check.
Roger that. And we did lose comms with Houston already. Well, they still have data on us, but we lost comms because we're in burn attitudes, which is not good enough to get comms. We should be looking at star 26, and that's going to be the angles provided here. Like so. Yes, you guys like the music. It's from Heartbound. The person who created Heartbound said he would not DMCA anyone who wishes to use the soundtrack, so I bought it and I'm using it. Very nice of him. If you guys don't know him, he's extremely popular on YouTube, so I'd be very surprised if you don't know him, but his name is, well, everyone always calls him Thor. But he's really popular, so I'm sure you've seen his YouTube shorts before. He used to work at Bethesda. Alright, let's take a look at the engine temperatures. They're approaching a good point. For me, you know what? I think I'm gonna turn on the fan. It's toasty. There we go, fan is on. And I do see the weather approaching. Yes, that is actually how the sight on the optics works. It auto-acquires the stars. The Verb 41, now 91 that I entered, that's manual pointing. But, let's see, how much time do I have? There is, of course, automatic pointing. Here, if you check this out. This stuff is not in the optics. So it will look like this. And it will automatically acquire any star you want it to acquire. Like this. And that's the star right there. And then you take over manual control and you do your mark, right? Because the difference between the auto and the manual is the drift on the IMU. So that's how that works. Verb 34, enter 00. But yeah, that's how that works. Ooh, look at the moon now. That's awesome. I think we're due to get our seats put in. But that is just... wow. That's just wow. 10 minutes. Line heaters off. Verb 37, enter, 40, enter. Everything's rate 2, okay. CMC in auto, proceed, and we transfer guidance to the burn program, which is gonna fine tune that burn attitude. And now we just get those circuit breakers plugged in for the engine. Direct voltage and the SPS pitch and yaw motors. Translation on. Alright, and now we bring her down to 6 minutes.
Here we are, 6 minutes. Battery is on. Thrust vector control on. And let's do our trim setup for the gimbal engine, or for the engine gimbal. Pitch 1, yaw 1. No manual thrust vector control, good. Pitch 2, yaw 2. Minus, plus 0, minus, plus 0. And the trim is minus, sorry, that's plus 1. And minus, plus 1. And minus 0.2. And verify manual thrust vector control. Pitch up, pitch down, yaw left, yaw right. Manual thrust vector control is in. We can see that perfect engine swivel there. Good. Burn switch configuration. Transfer guidance back to program 40. And computer controlled trim check. Engine gimbal is in. And the computer will now load the trim. There she goes. T-minus 3 minutes. Setting rate to high. Verify SPS helium valves are auto, correct. Let's make a save here. Okay. T-minus 2 minutes. Bank B armed. Yeah, the moon looks really good. Okay, standing by for Disky Blank. Disky Blank. EMS norm. No ullage for this burn. Standing by for ignition. 19. 15. 10. 9. 8. 7. 6. 5. Proceed. Confirm the burn. 2. 1. Ignition. Both banks running. T-minus 6 minutes to cut off. You guys want to view the outside or the inside? right, we are standing by for cutoff. Yes, that middle counter will cut the engine off at 0. Notice the discrepancy between this counter and row 2. This discrepancy exists because the cutoff signal, if we need to go to SCS from collapse of guidance, the cutoff signal will be received by the EMS. And this needs to factor for thrust trail off. The computer already does that. So this is the actual delta V burned, and this is the compensated delta V when we cut off the engine. And then the trail off thrust will also be counted towards the burn. So this is why there is this discrepancy. But yes, cut off at 0, and the burn is complete technically like 1 or 2 seconds after that, when the thrust actually completely stops. Yeah, good question. All right, 2 minutes to cut off. Okay.
Insertion complete. Well, not actually. It's not actually complete yet. Believe it or not. Alright, I see the questions. I'll answer them when I get to there. Our lunar velocity is 29,240 feet per second. So I believe that's roughly 5. Yeah, I don't know. Right, because this is all additive, right? So here's the velocity, but like relative to the moon, I don't know. But this is it relative to what we started with, right? Do not trim. We don't even need to trim anyways. That was a picture perfect burn. Our orbit is 169.7 by 60.0. Looks good. Proceed. CMC free. 00. Enter. DET stop. Reset. So, lunar orbit insertion 1 is complete. And now we need to do lunar orbit insertion 2. Da. Verb 66. Roll 180 degrees. Pitch down 70 degrees. Y'all left 14 degrees. Right, so SCS for this definitely. Roll to 180. That moon. There she is. Yeah, pretty soon you get to see why the moon was looking the way it did when we were approaching it. In Apollo 8, the sun is shining on the backside of the moon and dark on the front. But for these landing missions, it's exactly opposite, right? So you'll see that our landing zone is actually in the light. And this is why. Let's speed this up a little bit. So now we need to pitch down 70 degrees. So that's 40, 30, 25 plus 70 is approximately 295, yeah. So pitch down.
Here we are at 295. And we do need to just roll a little bit more. And y'all left 14 degrees. And there she is. Okay, ordeal initialization. Verb 82, enter, proceed. Let's grab our calculator. 169.7 plus 60 divided by 2 is 114.85. Good. $288.4 and increasing. So 288. Yeah, just a couple clicks here. Perfect. Let's watch it into 291 degrees. Perfect. Okay, that's good. Maybe if I had to suggest just one clip up like that. And now we wait for acquisition of signal, which is 76, 20, 56. Right, so we can cruise along. And very shortly, we see the Earth. At 3:15, okay, hold up. Now we must do orbit rates. Yeah, I introduced the commands just by clicking the keys. Verb 37 enter 00 enter. Yeah, just like that. But there she is. We've got Earth acquisition. So let's do verb 64 enter. So minus 22 plus 0, roughly. Exactly. AOS Goldstone. Nope, AOS. Yeah, AOS Goldstone and Madrid. Yep. And here we go. We've got acquisition on the high gain antenna. Let's increase that signal strength there. That is about as good as it's going to get on the signal strength, unfortunately. I can try another Omni, but yeah, they're not much better either. So Houston's going to be just a little bit in the mud, but it's something we'll have to deal with. And there's orbit rate. So now we literally just sit here and wait for Revolution 2 AOS. Once we complete an entire first orbit and we come back to exactly this point, we very simply just do our lunar orbit insertion 2. So I think we can say waiting for Rev 2. Like so. So I think it's appropriate to speed us up now. And we can see that as we come out to the other side of the moon, we drift really high, right? Because orbit insertion needs to be done in 2 parts. And here down, there's Tranquility Base. There is the landing site. And by the time we go to land, this should be in the light. Well, actually, we're not even going to land on that spot, believe it or not. We're going to land on the landing point that they were actually supposed to land on. So, yeah, kind of different, I guess. Goodbye, Earth. And there's LOS, and here's the sunrise. And that officially starts Revolution 2. If you're wondering why I keep going back inside, I'm looking at the ball to check on the orbit rate. You can see this ball is moving and this ball is not. That's because this is our orbit rate display right now. Since we're navigating with orbit rate, it's important. And here we are, acquisition of signal. And let's just verify high gain antenna does indeed have AOS. At pitch minus 18 and yaw roughly 0. And then we can see, after all is said and all is done, LOI 1 and we have 39.5% fuel. How are you able to fast forward? Right. So, flight sim guy. You see the switch? This is called pulse code modulator. When you have this set to high, it normally is everything, all of the telemetry, the computer and everything runs at a higher clock speed. So when you do 100 times time factor, the system, goes haywire as you've experienced. So taking pulse code modulate on both vehicles to low and just leaving it there, is good. I always leave it for the CSM since it's not really doing anything that would require it to be on high. For the LEM, I do it as it tells me. And if I need to time skip, I just turn it off, I time skip, and when I'm done, I turn it back on. But both of them need to be low. If you go into LEM and set it to high and you come back to the CSM and you time skip, you're also going to go haywire. So this is how I keep it from shit in the bed. And I also have a very expensive computer with R9 processor. Or no, R9. I got a 3060 Ti and a 3600 processor, yes. So, very expensive computer. But assuming that you're up to the standard of what it is that we are using today for gaming, then pulse code modulate will get you that times 100 speed. Yeah. NASP devs say that you should only go at most times 50, but I'm sorry, that's just way the hell too slow. Yeah, I do every once in a while, I do get a lag spike during launch on staging where this causes an engine flame out, and it's very annoying. I've had that on live stream one time, and I have a video of me doing the abort procedures. It was actually really cool, to be honest, because it was the first time I actually cared to do the abort procedures. But here we can see our lunar orbit insertion 2. Verb 37, enter 00, enter. And now we do uplink telemetry command module accept, and we're going to wait for comp activity. In the meantime, I'm going to open up the preliminary advisory log files and copy that down. So with the times 50, you actually go in the settings and you tell the computer, hey, I only want you going forward times 50. And then when you press T twice, it will sort of go to 100, but then snap to 50 before it actually goes 100 times speed. Yeah. So that's how that works. I'll put a setting on how to cap your fast forward because I did used to accidentally time skip times 1,000. By just, your finger every once in a while it twitches and it hits a button twice, right? So very bad. So you cap the time acceleration in the settings, yeah. Anyways, we're going to accept the uplink now. That's a CSM state vector and a target load.
Yeah, Ishtvan, if you want after the stream, you can actually see me if you're really curious about the power of the optics. I do a rendezvous with the S4B in orbit entirely using the optics and nothing else but the optics and the computer. That is how powerful those optics are. So if you're curious about that, I do have a stream up. It's on my Apollo GNC tutorials videos. Uplink telemetry command module to block. PCM bitrate is good. And verb 37, enter 00, enter. I figured for the Lunar series, I wouldn't do a lunar orbit insertion tutorial because I already have an SPS burn tutorial and they're literally exactly the same. So I'm not going to do a lunar orbit insertion tutorial. I have decided. But when we get to the LEM, everything's got to have a tutorial, so it's going to be crazy. Right, so at 75 hours, we're going to do a preliminary LOI2 systems monitoring. And then away we go at T minus 60 minutes, which will be 80 hours, 79 hours, 19 minutes. So that's not bad. And let's change this to lunar orbit, or sorry, lunar insertion burn 2. There we go. And I'll dismiss that so it's out of your guys' view. Enjoy the external view while I be right back to use the restroom. This time you don't rotate retrograde for the burn. We do rotate retrograde for the burn. Yes. We don't get into attitude this early. The burn is in approximately 2 hours, 1.5 hours, right? If we got into a burn right now, it would be catastrophic on our RCS budget. So we actually are going to get into burn attitude at roughly 35 minutes prior to the burn. We'll begin our maneuver to burn attitude. Here's our TEI 5 abort pad. Adios. So here we are, 79. And it says we need to go inertial at 79:19:06. rotate, retrograde, attitude. It's all the same thing. I'm so used to people calling it rotate. It's fine, right? We're a learning channel, so I will always use the correct terminology, but you absolutely don't have to. I understand just about every synonym for maneuver and attitude under the sun. So that is completely fine, yeah? Now we're going to switch to inertial. So we wait until we're 182 on the inertial, and then we go inertial. So bam, we are inertial now. And now we'll just tell it to sort of correct the attitude a bit to where it's supposed to be, because I think I was a little trigger happy on the time skipping and I skipped just a teeny bit too far, so we're off attitude slightly. So we'll just have that get corrected for us. Minus 45 and 180. And we're going to perform a P52 now. So right when we're in attitude, we'll start that P52. There she is, attitude hold. So this is a P52 refs mat, so we're going to come down. Let me just get the seats real quick. We're going to come down here. 0 switch off, CMC. And just so that you guys can see the computer better, we're going to up the numerics to like that much. There you go. We'll do verb 37, enter, 52, enter. Verb 22, enter, 3, enter. And proceed. Proceed. By the way, if you want the computer in this view, yeah, clicking right here at the very top right corner, just a little bit underneath that, and you get the computer display. It's extremely helpful. So yes, it wants us to mark Antares. Luckily for us, Antares is actually blocked by the Lunar module, so we are going to go manual, and we are going to redesignate to star 37. So we'll do that redesignation now to star 37. So to redesignate, you take a mark on the desired star. That was terrible. Let's reject. You take a mark on the desired star. You press proceed, and then you do verb 21, and then you just simply enter the 2-digit star code of the star you actually marked, and you hit proceed. Now it'll find you an entirely new star that's 30 degrees away from this star that you redesignated to. And then you take the mark. This happens a lot when the lunar module is docked, so it's pretty normal. Now we just need to get the IMU and the GDC in agreement again. So this, you simply line up everything. I do a little time skipping to get through this just a little faster, because it is very slow, and the noise is annoying.
You hold GDC align and don't release until the change is finished, and that is a really good alignment. Right, TIG minus 40. So TIG is 80 hours, 19 minutes, 6 seconds. 40 away from 20 is roughly 40 after, so we'll start it then. We got about roughly 25 or so minutes to kill. And it's not entirely crucial we stay in this exact orientation, so I'm going to save some fuel by doing that. Yes. And now that the burn is complete, I think we could get the Heartbound music back on. I think we're gonna do 4 shadows. How's this one? I think my favorite track so far has actually been Cave Wave. No, I lie. Was it Middle Management? I don't remember. It was a really nice classical piece, though. A Moment in Time? I think it was this one. It's just a really nice piece. Desert Winds is nice. Jupiter and Uranus are back there. No, we did go a little far on that. That's my bad, but that's all okay. We do have time to catch up. I am a professional, so 80, 19, 6.14, good. All that, and that, good. Perfect. Okay, we've got our burn started here. Let's turn that just a little bit down. Okay, let's check those propellants. Temperatures are great. Nitrogen levels are good.
Loss of signal. All right, let's load the burn program. Get our circuit breakers plugged in. Proceed. All right, EMS test. EMS test looks great. Delta V counter. Delta V counter is looking good. Looking good. Verb 48, enter. And we're gonna load for 2 jet ullage now. So it's gonna be 20101. Enter. 111111. Enter. Proceed. Command module weight is 38992. Good. Proceed. Gimbal angles. (1.49) and minus 59. Proceed. Verb 46. And delta V from the pad shows 131.2. All right, non-essentials to main bus B. And we are ready for the insertion. Star check coming up in 5 minutes. So here we are, oriented in a retrograde. Verb 41, now 91, enter, plus 33520 plus 05700, and we should theoretically be looking at star 26. And I would say that that is good enough, yeah. So verb 41, now 91, enter, plus 00000, enter, plus 00000, enter, and 0 switch on.
T minus 10 minutes. Let's check our GDC. And I would say that that is good enough for a burn. Ordeal off. Coming up on 6 minutes. All right, batteries on. TVC's on. Seat in. Oop. Exactly, backwards. There we go. Five minutes. No manual thrust vector control. Good. Pitch to start. Yaw to start. Minus, plus 0, minus, plus 0. Pad values are minus 1 or plus 1.5, that is, and minus 0.56. And make sure we've got manual thrust vector control. Very good. Yep. Very good, very good, very good. THC neutral. Rate 2. Proceed to transfer attitude control back to P40. At 1, rate 2. And enter. Proceed for computer-driven gimbal check. Scale 50-15. Computer loads trim. Trim load. Rate high. Helium valves in auto. Standing by. T minus 2 minutes. Thruster bank A armed. Standing by.
Translation.
Okay, here we go. Ready to arm bank B. Ullage start. Nine, 8, 7, 6, 5. Verb 99. Proceed. 2, 1. Ignition. Shut down. Looks good.
Rotation.
We could trim this all the way down. What's our current orbit? That's honestly, it's good enough. But we can trim it down to like that. Should be good.
Rotation.
Proceed. Verb 82. Enter. Proceed. 00. Enter. DET stop. Reset. The flight is going great. We have just finished lunar orbit insertion. Burn 2. Literally on the dot, pretty much. SMRCS is looking good. We are at 37% fuel left in the main engine, and we've just finished lunar orbit insertion. So we're ready for the mission. Verb 66. Enter. And let's get that charge on battery A. The surface looks really rough below us. Wonder if we could use the sextant to search for some unusual geological features. I think you're referring to KSP. But no, well, the sextant is pointed in exactly the wrong way, sorry. So LOI 2 was occurring at, so we need to wait to 39 minutes. Well, in that case, I'm going to be right back real quick. I just have to open the windows for, 25 minutes to... We're currently curing the screed work downstairs, the new concrete for the floor heating. So I'll be right back to do that. So don't go anywhere. It'll take... Oops, sorry for hitting my mic. It'll take like 2 seconds. Alright. We will be looking at some creator stuff. Don't worry. Don't worry. Yeah. Madison, if you're encountering problems where the S4B is not coming to a complete stop, like in NASP, that's obviously not possible in space. In NASP, you'll be moving a little bit, but the number should be moving less than 0.02 per second. If it doesn't get to that point, the minus key will kill all rotation. Yeah? The minus key will kill all rotation if you need it. I used to have to use it back when I was learning as well. Look, there is a trench. Yes, this is real, by the way. This line of craters is real. What's backspace do then? It does kill all rotation, yes. In fact, if it helps you, you can undock, immediately hit backspace, and then translate forward. This is the way I used to do it back when I was learning. The trench goes from here to here. Craters are everywhere, yes. But yeah, this tip does not work in NASP. By the way, there is no kill rotation in NASP unless you cheat. So just keep that in mind if you're going to be doing NASP at some point. But the attitude is way, way, way more under control if you follow their procedures. So it shouldn't be an issue. Petrie used it and he called it cheating. Yes, I actually was the one that begged for it to be put in because I couldn't do it without it. And now I'm a pro. But that feature is in actually because of me. All right, all right, all right. Let's see here. Wi-Fi is doing a little bit of the funny. So it must be done by some meteor skipping across the landscape. I don't know what it's caused by. It could be a coincidence. It could be meteor skipping. I have no clue. And well, I'm still learning, so better to have kind of cheat to understand the basics. Yeah, that on there, right? Copernicus crater. I don't know, to be honest. I'm not hip on my lunar geography. The map is not labeled, but we are about halfway between the sunrise and the sunset, and we are approaching the actual landing site of Tranquility. So if that gives you any indication. Yeah, the view is absolutely tremendous. You're right about that. 3 more minutes, and we're going to go into ordeal attitude. Or it says wait for lunar orbit insertion 2 plus 20 minutes. That's 80 hours, 39 minutes. But then it tells us to maneuver to this attitude by... Okay, we're just going to do that now then. Uh, 60.8 plus 60.1 divided by 2 is 60. So it'll be about right there. $238. Good. And now we'll just down, and we'll maneuver to attitude roll 18000. Pitch is going to be 29300, and yaw is going to be all zeros. Proceed, proceed. Yeah, the lunar map is nice in re-entry. In orbiter, it's lacking. Yeah, I do remember that as well. Well, we've got Rev 3 AOS, and once we're in attitude, we'll begin orbit rate at 315. Okay, in approximately 7 minutes or so, I've got to go close the windows. Sea of Tranquility! Yes. Yes, it is coming up. Very soon. It's over there. Alright, this is taking too long. There you go. Yeah, no, I'm just saying that because I'm actually a little bit behind on the flight plan, due to a discrepancy between LOI 2 burn, the instructions, and the actual flight plan itself. Alright, that's good. Let's get that AOS. So 67, roughly 360, and 67, roughly there. There you go. There we go. Yep, she's in. Okay, there she is. Thank you, thank you. Yeah, that was a little stressful, but we're there now. Better late than never. On most stuff. This is an okay thing to be late on. The rest is not. So we are going to dismiss that message now, and we are open for more questions. Yes, look at that. Ah, beautiful. Still not over to the Sea of Tranquility yet, though. All right, it's roughly 3 minutes, so I gotta go down and close the windows. And then I think we're gonna have a little bit of dinner shortly. I'm excited to try... What are the actual orbital parameters? The actual orbiter parameters, right now, we are... .8 nautical miles by 60.1 nautical miles. Our time from free fall is, well, obviously not counting down because we're not going to re-enter the atmosphere, so those are our orbital parameters. I'm excited to try and get there so I can continue my campaign and actually beat it while enjoying a nice story. Yeah. Very true. Very true. I'm hoping that I can get those reentry tutorials at some point in September. Just gonna open the press equalization and begin equalizing the pressure here. And we just wait for our MCC update now. This is not the Sea of Tranquility. The Sea of Tranquility is on the other side. Speed is... hold on. Let me get you that in metric. So we are 109.0 by 109.4 kilometers high. We are presently at an altitude of 109 kilometers. Our eccentricity is 0, and our velocity is currently 1.629 kilometers. I assume that's in per second. 1.629 kilometers per second. Yeah, Rebel hasn't even re-entered in Gemini yet, so this is why I have been sort of slower with the tutorials. I hope Rebel stops by when we land on the moon. I've got to say, if he's not there, I'm going to be so upset. "109 kilometers above the surface." Yeah, he never has the time, but now that he can time skip, it should be life changing for him. Yeah. While we're waiting on that MCC update, I am going to go close the windows downstairs. It's that time. Yes, our altitude is 109 kilometers. Yeah. 109.4 by 109 kilometers altitude. Yes, Windows. I'll be back. And here is the Sea of Tranquility we're looking at now. I can tell because there's Tranquility Base. Alrighty. Yes, the landing site is not actually here. It's gonna be different, because we are landing in the real landing place of Apollo 11. Also, I do wonder if the sun is actually in the wrong spot. Well, I've never had this problem before, so we'll see where we land. Hopefully in the sunlight. Okay, P-22, landmark tracking. We are now going to maneuver spacecraft to 180, 1960. And we will go to inertial. Yeah, that's going to happen a lot now that we open the hatch equalization valve. Because it needs to repress the cabin. So it's just something we have to deal with, but... All right. We are inertial attitude hold. We do still have a lock with the radio. Good. Or the S-band, that is. And tunnel pressure has fallen to 0 delta pressure. Good. We'll do a P-52. And then we're going to power down the optics, and we're going to go inside the LEM, do some very basic system checks, come back out, and turn the thing off and go back to sleep. So yes, I, for one, am going to cook myself a lasagna. So not much too interesting coming out of the windows or the external view now due to, well, sunset happening in a few minutes, but feel free to watch the sunset. What's your favorite spot that we landed on the moon? I like Frau Moro Highlands. I kind of don't like Frau Moro Highlands. And the reason I don't is because it was safe and not particularly geologically interesting. My favorite landing site is the Apollo 17 landing site. And the reason is very, very simple. Until Apollo 17, they were operating on a fundamentally flawed theory about the way that the moon came to be. And so it wasn't until the discoveries made in Apollo 16 that they realized they were, well, kind of wrong. So Apollo 17 selected the landing site that fit the new discoveries they made. And because of that, it was the most scientifically productive of all of the missions. So that is why Apollo 17 is my favorite, is because that's where Apollo 17 is exactly where a lot of the theories of how the moon came to be became fact. That site is where we learned how the moon came to be. And that's why it's my favorite. Okay, we got our procedures here now. Yes, I think it was Taurus Litro. I don't know where they were going to land. The landing sites for each Apollo mission are, of course, they're selected way ahead of time, but they're not selected as far ahead of time as you might think. Mostly because there's a lot of debate. There's a lot of arguing among geologists about where exactly they wanted to land on the moon. Right? It was a huge argument. They spent days coming up with the landing site for Apollo 15, right? So this is I don't know. So I do know that had they not canceled the moon landings, we probably would have already landed on Mars. Albeit not in the most economically feasible way possible, but we definitely could have done it. The Apollo applications program had a Mars mission that they wanted to do. Not Pro, I meant to hit Mark. But of course that never happened, and while I don't think Starship is the most economic way of getting to Mars either, considering the amount of refuels required and the type of fuel, but at least the rocket's reusable, so we have that. Well, at least we think it's reusable. I'm not going to say anything ahead of time. Apollo 18 was scheduled for Copernicus crater. Yeah. I don't know where Apollo 19 would have been scheduled, but I think those were the only... I think it went up to Apollo 20, if I remember correctly. I'm not sure about that, though. I know 18 and 19 for sure. Yes, yes, microwave. I know, I know. I'm getting there. Exactly. It's more practical as a cargo vessel than it is a human transport, at least at the moment I think it is. It could prove itself. I'm not going to roll anything out, and I sure do love to watch the launches. You know, so SpaceX, go, go, go. I hope they can achieve everything they're promising. But we do have to remember this is Elon Musk, who is famous for never delivering anything he promises. So I'm not keeping my hopes too high, but I'm keeping them high enough to stay enthused about Starship. What? Scheiße, that's hot. Woo!
And if I'm correct, Apollo 20 was for Tycho, where Kubrick found the monolith. Apollo 15 was going to be for Tycho at one point. That I know. Tycho Crater, where you can bury the entirety of NASA in monolith, yes. Oh, scheiße, that's fucking hot. Oh my god, ceramic and microwaves don't go together. Guys, ceramic and microwaves don't go together. That is fucking hot. I have zero faith in NASA at this point. I'm not even gonna lie to you. SLS is cool and all, and it delivered on what it promised on the first launch, but because their contracts with Boeing, let's just say that there was definitely a leniency from NASA with the schedule problems. I personally would have canned them. The budget wasn't managed properly. But yeah, no, to put it in perspective, this is why I have no hope for NASA anymore. The space shuttle. I don't need to explain about that. The culture of that was terrible. But secondly, I mean they were out a entire Saturn V, the entire modern day cost of a Saturn V rocket, and they had nothing. They didn't even build any piece of it yet. It was just a stupidity from the fucking Boeing. They were out an entire Saturn V rocket, and they hadn't even left the paper yet. So this is why I have no faith in NASA. Because they're a bunch of pushovers. They're not like the old days where when you're behind schedule, it was we're threatening to go to a different contractor. That doesn't happen anymore, right? SLS is not the space launch system. It's the Senate launch system. They're glued in. And part of this is the Senate, yes. Part of this is Trump's fault due to he was the reason the project started in the first place. Artemis is actually Trump's brainchild. Artemis is the brainchild of Trump. Trump was the one who started the Artemis program, and when he proposed it to the Senate, he made a ton of promises with certain contractors to work with. So this is the reason we're stuck with those contractors now, and there's nothing else we can do. But yeah, the Artemis is made by Donald Trump, so some things I don't like about him and some things I do like about him, and Artemis is one of those things that I do really like.
Yeah, no. It was not Obama, because Obama was the one responsible for making all these private companies able to do their own thing with space, right? The only reason SpaceX can exist is because of Obama, right? So this is why Elon Musk used to be voting for Obama a lot and used to be voting Democrat, because it was Obama that allows SpaceX to happen. Yeah, Starliner is oof. I get it. Had I been in their position, I might have approved it for launch as well, because from experience with the space shuttle, which is also a lot of Boeing technology, their helium leaks on the space shuttle were far worse, and it did not affect the RCS system at all. But the problem is the OMS isn't pressurized with helium. I don't think, at least where it was, the leak was in the RCS. The 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 RCS on Starliner is completely responsible for getting back home. It's all the same fuel system, right? Unlike the shuttle, which had the OMS, the Starliner sort of has a more powerful monopropellant jets. And that's the problem, right? They're having the helium leak. They're they're saying this helium leak fits a launch because of some previous helium leak that happened on the space shuttle, but that was with the RCS. It wasn't with the OMS. So it's relatively incomparable, even though it's the same fuel, different pressures, different thrust. So they made an error on their part, and had I been a CEO or something, or a higher management, I may not have known enough about that to say, let's not launch. Now, that's from a business standpoint and putting myself in their shoes. If it were me and my will alone, why the hell would you launch with any problems your first launch with people? You know, at down the line, maybe before people go on, yeah, obviously, so you can know what sort of failures are tolerable, right? Like they launched Apollo 11 with a leaking valve in the hydrogen replenishing system, right? But it's yeah, the Starliner is a lot like the Gemini, right? You've got your capsule RCS BS, and then you've got basically the in orbit, all that stuff, the translation, the rotation. So it's basically a copy of Gemini almost, but in the style of Apollo. So the attitude control and the thrusting are not independent of each other. It's the same thing in any spacecraft almost. Like Apollo translation is done also with the RCS. So that's their problem. The space shuttle had two completely independent systems. So I personally wouldn't have launched it, but I can also understand where they're coming from, if that makes sense. No, it's perfectly fine for an Earth orbit vehicle. Dragon has the same thing. It's just that SpaceX is more reliable. You know, they don't launch with any problems at all. And part of the reason is because SpaceX never had the time pressure that Boeing has. Boeing didn't even have a rocket built, and they're like 2 years away from the end of the deadline. They finally get it up. They're a year and a half away from their contract of getting to the ISS to get their licensing from expiring. So they're under extreme time pressure. And this is why they made the wrong call. Their previous work on Apollo and the space shuttle gave them data that really doesn't apply. Had Boeing done Gemini, they probably, and Gemini had the same helium leak, they probably wouldn't have sent it up. The planes and the spaceships are two completely different. Like, they have nothing to do with each other than the name Boeing. It is two completely different things. Different managers, different engineers, different everyone. The only thing in common is Jeff Bezos. That's it. Or, not Jeff Bezos, sorry, that's Amazon. Whoever the CEO of Boeing is the only thing they have in common. Just the CEO at the very top. Otherwise, they're completely different. It's essentially like one guy owns two businesses. Back then, we did try to risk the people. We didn't know we were, but trust me, there were some things back then that were... Every single Apollo mission almost ended in complete and utter failure. Every last one of them. The safety rating on an Apollo mission is 1 in every 5 Apollo missions will result in the total loss of life, the vehicle, and the crew. They were just really lucky. And people in the Apollo program will even say that it was luck. Yeah, the space shuttle is actually... By the end of the space shuttle program, the space shuttle itself was a far more reliable vehicle than the Saturn V, with a safety rating of 1 in every 400 or 500. Before the Challenger explosion, it was, I think it was 1 in every 3 would explode. So by the end of the space shuttle program, it was really safe. Minus a potential for another Columbia to happen. But the odds of Columbia even happening in the first place were pretty low. It just so happened to strike the wing, which is a really, like, small part that it actually struck this side of the wing. It's really unlikely, but it happened. So they should have fixed the insulation on the tank. But other than that, it was predicted to be 1 in every 500, whereas Apollo was 1 in every 4 or 5. So, yeah. Early on with the boosters, it was 1 in every 3 would cause total loss of life. So, Space Shuttle was really not safe until about halfway through the program. But after Columbia, when they made all those new procedures is what really made it safe. Columbia couldn't happen again because their new procedures with the arm to look at the tiles and all of that, and they also made it impossible for the DoD manager to refuse to turn around a satellite, which they did. the DoD manager at NASA refused to turn around a satellite to inspect Columbia. So, poor decision on his part, because Columbia could have been fine if they actually turned that satellite around. What's that in percentages? You just take 1 and you divide it by 400 or 500. So let's do 1 divided by 450, just to be a little conservative with the estimate. And that's 0.002%. Or sorry, that would be 0.2%. Yes, that's 0.2%. Which honestly is still pretty high. They did have an ejection seat in the space shuttle. The problem is that you can't eject all 7 people. So the idea was it's better to have none than to have just one for the commander and the pilot, because then it becomes an ethics problem, and I don't blame them for that. If I were to redesign the space shuttle, it would not be ejection seats. It would be the entire crew capsule, as you say, the entire crew capsule to eject, like what N9 did in his For All Kerbal Kind series. But that's entirely infeasible. That would be so much weight, the space shuttle wouldn't have even been able to launch with the current vehicle it had. So it's up in the air. But it was premature. Yes, absolutely. Yeah, the launch cadence was bad. If I were to redesign the space shuttle, I would also make it an attachable ablator heat shield. So they could build the next heat shield and then just put it on right away. Right, they could build the next heat shield while the space shuttle is doing its mission and put it on right away. Take the old one off, put it on. Ablator heat shield sort of idea. That'd be incredibly difficult, but I would argue probably faster than 1,000,001 tiles. So, ablator heat shield, maybe in segments, you know, wings, belly, or just one big thing. You just but it was the tiles that were slowing them down more than anything. It was the tiles. Elon Musk is using new material that's a little more resilient, so less tiles are breaking. And also, he's doing the very smart thing of manufacturing the tiles before the thing returns. Right? These tiles are made ahead of time, so it's, you know, you squeeze every ounce of cadence you can out of these things. They could have done it faster as management issues. I have a piece of the Apollo 11 vehicle. Yeah, I have a piece of the Apollo 11 vehicle. It's about 50 microns by 50 microns, and it's a tiny piece of that gold Kapton foil underneath the Mylar foil outside of the vehicle. So right, it's the whole silver thing is Mylar, and underneath is Kapton, is gold foil, right? And underneath this, I have a small, like 50 microns by 50 microns piece of that. I gotta say, that lasagna was absolutely spectacular. It was really fucking good. Let's make a save real quick. All right, do you guys know what time it is? Yeah, time for another save. Time for a new external MFD. It's really small, 50 microns, but it is cool. LMP, intervehicular transfer to lunar module. New crew and cabin, 2. Switch to lunar module. Hatch is open. Adding LMP to cabin. Okay, floodlights all. Exterior lighting is off. Descent water open. Ascent oxygen open. Repress auto. Cabin repress circuit breaker closed. Circuit breaker utility lights is closed. Utility lights to dim. Initial circuit breaker positions. So far, so good. I'm just letting the checklist verify all this stuff for me. Initial switch positions. Altitude set 60. This model is definitely way more accurate. This model is the bee's knees. Voice-operated transmission sensitivity goes to 7. Yeah, no, the Lem is my favorite vehicle, easily. It's no contest. think that typo. I think that's a typo. It's supposed to be 255. It's we're not in the right attitude to see the moon yet, but we will be eventually. Now, Istvan, this is going to be, I think it's going to be your favorite, one of your favorite things to see. Let's quickly start getting in, no, we don't need to get into attitude yet, but I think this is going to be one of your favorite things to see. Going to happen very soon. Let's make a save. Alright, while we're maneuvering, I think it would be cool to sit in here, see if we can see the moon at all. I don't... we might just barely be able to see it out of the lunar module pilot side. Hello, it's like some two creepy eyes down there. There we go. Potentially out of this window, we might be able to get some lunar action going. We're not in the right attitude anyways, but... Well, we might be able to get some lunar action. Let's see. Here, yes, let's see here. Oh, there it is. Yeah, we're definitely not in the right attitude for this. We could do that. We can become a dwarf. There we go. Transporting Cinderella to the moon. Yeah, it'll come up short. It'll come up soon, yeah. Alright, while we're maneuvering, I'm going to go wash my plate real quick, and once I'm back, then I'll initiate time skipping. Yes, it did. It's a glare shield. In fact, the lunar module even had window shades that could be pulled down. Of course, they're not modeled here, but they did. They're not modeled in re-entry either, so... Oh man, that's looking amazing. I'm guessing that's good to keep good vision and not be totally distracted by instruments. No. It's a glare shield. But yes, no, this view is it's the best. This is why the Lunar Module is my favorite vehicle. I mean, come on. The command module, you can't see anything, even when you're docked. It's blech. Not enough windows. Although the command module does have one really cool capability, which we are going to see in a few minutes. Which honestly might be better than a lunar module window, but you guys can be the judge of that. Okay, dishes are done. Now I just gotta wipe off that sink real quick. Here in my home country, the water is filtered by moving down a waterfall across mountains and stuff. The snow comes down and then the snow melts and it gets filtered by the rocks flowing. So we have no water purification systems, and it's the best water in the world. Out of all the countries I've been to, it has the single greatest water ever, just period. But it does create some calcium white spots, exactly like it would in the US. And so I have to wipe that up immediately. But yes, it is, it's time to, Oh, no, we are still not in attitude. We're still very far from being in attitude, but yeah, here we go. Look at that view, huh? This is really something else. I'm from the Europe. Actually, I think my YouTube channel may actually tell you which country I'm from because of monetization reasons. Those craters look suspiciously like a door to me. Are you saying I live on the moon and that's why I'm so good at coming back to the moon? Now we're in attitude. Beautiful. Now that we are in attitudes, we no longer have connection. So we need to go Omni Bravo. That should give us our connection when we do get it at some point. And now, optics needs to come on. And then we 0 for 15 seconds. Here, you ready for something that's gonna blow your mind, Ishtvan? Check this out. How about that? Yes, the reason is because I'm in college in the US. So then the streams get to a normal time for you, and then I come home, and I didn't work this summer, so I'm always up streaming early for me, which is really early for you guys. And some days I stream later because my husband has shift work. So, you know, I sort of stream at different times. That might not make sense to anyone, but it's just the time I have available, right? If he's not here, I'm streaming or cleaning or cooking, and if he's here, I'm spending time with him. So. This is not even the max magnification, no. The max magnification looks terrible because it's a video game, but this is the max magnification. If it was in real life, that would be looking so much better. And in fact, you can even see the lunar module in complete detail. This is one of the things that absolutely just blows the LEM away. This is the one thing that the command module does better than the LEM. Yeah, we're holding inertial, and the optics are stable, so you'll notice we can see the horizons and stuff, and that'll come up soon. Yeah, close-up does suck because the computer game. It looks better in real life, obviously. The close-up looks really great with Earth, though. The LEM does have a scope, but its operation is much more confusing. And so we'll talk about that later. Verb 37, enter. 22, enter. Proceed. This is going to be a known landmark. Landmark coordinates plus 02000 plus 32750 minus all balls. Proceed. And yes, we do get the program alarm right now because we don't have tracking, but we will get there. Yeah, the LEM doesn't have a sextant. It has a telescope. They're different powers. So I'll teach you guys how to use the alignment optical telescope in the LEM. Just be warned, it's complicated and it's going to take a lot of practice. P-52s are not done just by marking a star in the middle, right? You've got a whole can of worms that you're going to open up if we start talking about the optics now. But we'll get to it, don't worry. And of course, because the LEM is in the way, we have to wait. Here we go. So, roughly, okay, I see where you're getting at. Right, I see where you're getting at. Totally forgot where we're supposed to be marking. Right there, okay. There she goes. She's in. But yeah, as you can see, the optics will automatically track any landmark I want, any position on the surface I want, just based on the coordinates and the altitude. That is really cool. Of course, until it hits gimbal lock. But let's see what our deltas are. Zero. Nice. Fantastic. Look at that. Such an excellent navigator. Thank you, thank you, thank you. You're welcome. Adios. Unfortunately, this is not incorporated. If it was, I could flex, but it's not. Alright, back to the LEM. Here, we can fix these weird rendering bugs. 1 second. There we go. I just put the whole surface in. Yeah. Still weird. Yeah, it'll get better. But yeah, how did you guys like that really cool optics landmark thing that the command module can do? It's pretty cool. Pretty cool. All right, comm activation. Transfer lem to internal power. Certainly. Also, real quick, we're going to add the O2 hose. And now let's transfer lem to internal power. When I look at the screenshots of the LEM interior, I gotta say it wasn't particularly great. Yeah, the interior just doesn't look as nice. And also a ton of stuff is missing. But the interactivity is, in terms of EVAs and stuff, pretty cool. All right, LEM power reset off. Circuit breakers open. Now we maneuver to comms test attitude. Pitch is 8. Yaw is 270. On high gain. At the same time, let's power down the optics. They have... Is that Velcro strip next to the disky for a cover I've seen in some of the footage? No. Well, yes and no, actually. In here, no, it's for these. In real life, it's for these and a cover, yes. They have MFD's displays projected over the screen and was pretty confusing with all those lines and markings rolling and tumbling all over the screen. Oh, yeah. I can see how that might be confusing. But yeah, so we've got boost checklist and aborts, TLI checklist, VAC transfer to ECS, And here we've got SPS burned. We've got transposition and docking. We've got entry checklist, EVA checklist, contingency EVA. Over here, we've got power loss checklist, undocking separation, emergency cabin repress, TPF, commander aborts for mode 3 and 4. Here we have, I think that's it for this panel. Yep. Nothing else here. Over here, we've got the DAP reference, the Saturn V boost reference. Nothing up here. Nothing here. Nothing here. Here we have the reference for the placement of equipment, as well as lunar orbit insertion limits. Over here, we have LMP boost abort. We have the EPS, ECS aborts, SPS burn rules, landings checklist. We've got AC power, loss of comm. All very helpful stuff, to be honest. Yeah, you can't EVA in reentry, but you can depress the cabin, open the hatch in space, and all that jazz. So. Alright, verb 64, enter. And let's just verify, do we have comms? Yes, we do. Optics is powered down. Back to the LEM. Let's make a save. Always make a save. Always make a save. Always make a save. All right. EPS. Translunar bus tie. Exlunar bus tie. Close. Close. Utility lights dim. COM. VHF B transmitter. A receiver. CDR audio. Instruments. Signal conditioner 1. We'll need glycol pump 2. Signal conditioner 2. We'll need display for the EPS. We'll need ECS or descent ECA control. And cross tie balance loads open. And select CDR bus. If less than 27 volts, select high voltage taps. Nope, we are good on that regard, so we'll just fail. Circuit breaker COM, display closed. Systems engineer audio close. B receiver, A transmitter, power amplifier, transceiver, pre-modulated processor, signal sensor, and postcode modulator and telemetry, and ECS display. You can open the hatch. You can open the hatch. In NASP, you can absolutely open the hatch. It just takes a while. When the display says 0, it's got to actually perfectly be 0, so a little cheat I used to speed up is just depress the CM cabin a little bit, where you can open the hatch. Or if you're in the LEM, you just got to keep waiting. If you're in the command module, open the main hatch, you just got to keep waiting, right?
Transceiver, power amplifier. Let's go down voice backup, postcode modulator, bitrate low, VHF-B transmitter to voice, receiver on. On every single mission from Apollo 15 to 17, the command module pilot did perform in EVA, as well as Apollo 9. So, voice check. That was F1. That's voice check. Voice check. Good. Perform S-band voice check with CSM. Voice check. Voice check. Good. Look at that. We've got her in. Voice check. Voice check. And we're good. Bitrate high. Voice check. Looking good. Biomed right. Voice check. Looking good. Bitrate low. Voice check. Looking good. Voice check. Good. Bitrate high. Voice check. Looking good. Bitrate low and with ranging. Voice check. Looking good. Back to the command module. Now we wait for MCC update and we go back to CSM power. We're not on ordeal navigation, so let me just switch that around so it's less confusing for everyone. There we go. And we've got our abort pad looking good, and we're going to get our state vector update. Oh, by the way, Istvan, we did do the transposition and docking, and it is recorded. It's up for a tutorial, actually, in my Lunar series playlist, if you're interested in seeing that. All right, state vector update is complete. Switching back to the LEM. And in 15 minutes, we'll go for comm deactivation. And closing out the LEM. There's those two creepy eyes again from the planets. All right, comm deactivation. Here we go. All right, loading initial circuit breaker positions. Signal conditioner 1. And then it was glycol pump 2. And then it was all of the comm circuit breakers. Cross lunar bus tie, or translunar bus tie. Yep, all that's good. Other side now. Signal sensor, PCMTE, signal strength display, or signal conditioner 2, that is. Circuit breaker comm display, systems engineer audio, all of this stuff. Open, 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 open. Environmental or in, I don't know, electrical power system. There we go. Decent ECA control open. Translunar bus tie, cross tie balance loads closed. And utility lights off, off. Circuit breaker, utility lights. Open. And transfer to command module power. Yes, yes, it is a little creepy, but it's cool. I like it. Even creepier when it's in the CM. Here, check this out. Watch this. It is really quiet. All right. OPS checkout is complete. Descent O2 closed. Cabin or descent H2O closed. Cabin repress closed. Cabin repress circuit breaker open. Deploy window shades. We don't have those. And we can now remove the lunar module pilot and close the hatch. We can take the floodlights off too. And LEM is officially closed out. Yeah, I thought it was when he was inside about to open the hatch, but I might be wrong. It could have been when he was outside. And we could take the O2 hose disconnect now. There we go. So we can close out that. We've transferred the pilots using the Project Apollo MFD. And we've installed the hatch. And I think we can close the pressure equalization valve. And maybe not. I think we... I'm not entirely sure what the story on this one is. Let's see here. Yeah, I think we do need to keep that open. Which unfortunately means we're going to get plenty of master alarms during the sleep period, but... Hey, I crashed. I still crash, right? You know, when you get out of practice, you're still gonna crash. It's all about doing those quote unquote simulations before the actual moon landing, right? But I'm gonna try it without practicing at all, and we'll see. We'll see what happens. I think it'll be fun. Okay, curiously, here's the pressure. If I take it to LM press, and then I close the hatch, let's see. Let's do just a few minutes. Let's see what that's gonna do. So this increases. So we're about there. Let's see what this does. LM press. Back to LMCM delta pressure. Okay, so this is just going to, it looks like it might just keep going up without that equalization valve open. Which would suck because, damn, the equalization valve is going to cause a lot of really annoying alarms. But I guess we're just going to have to open her up. Tons of times before I managed to land a LEM. The trigger rage, which I released, or the tiger rage, which I released then at around 1 a.m. at night, was heard by all my neighbors. Yeah, no, it's quite annoying. Especially in reentry. Here you got really reliable save states, but in reentry it's not reliable at all. We are just gonna make a save real quick, and we're just gonna go outside. And I think we're gonna wrap up the Apollo 11 mission for the day, and the next day will be the landing on the moon. I do have about 15, 30-ish minutes. So I think I'm going to load us up something pretty fun. Let me load up re-entry real quick. And I want to show you guys something pretty cool.
If this capsule history of our progress teaches...
Whoa! Copyrighted music! Oh, heck no. Get out of there. Not gonna happen. Alright, let's see here. So, missions, Gemini, free play. Let's just do pre-flight because I don't have the time to do cold and dark. I'm gonna show you guys something really cool. I hope you all are gonna like this. This is what I want to get Rebel to try and do. Right. Here's what I want to get Rebel to try and do. Alright, so first of all, let's get everything set up the way it's supposed to be. Yes, this is Gemini. What are the failure rates? I have failures turned on. In Gemini, only the batteries can fail. Failure rates, I usually stick at around 30%. But for streams, if I want failures, you know, it depends on what I want that day, really. But here we go. Let's get this show on the road. Now, one very astute observation you may be noticing is that I am not going to run pre-launch program and align to the azimuth. Very, very astute observation, yeah? Check it out, right? Let's get a rate command. There we go. A very, very astute observation. So we get no roll program, as you've seen. This is all going to be in good faith. Trust me.
Good luck, all day. Roll is in. We have a pitch program. Roger, pitch program. seconds. You're looking good, 8.
I also heard you could take Gemini to the moon. That is not true. Gemini was originally designed to perform what's called a circumlunar flyby. So it was designed for that. It could never go into lunar orbit or anything. And you would need something way more powerful than the Agena. Something like the Centaur. The Centaur rocket with the Gemini could have done a circumlunar flyby. This was all it was designed for. Originally, they were drafting some plans like Big Gemini. I mean, they tried to do everything with Gemini, right? Big Gemini, Gemini with wings, gliding Gemini, fucking space shuttle Gemini. It was crazy. But the most that they were gonna do with Gemini was a circumlunar flyby using the Centaur stage. But none of the actual hardware that existed was capable of doing going to the moon with Gemini. Nothing they ever attached to Gemini could make it go to the moon. They would need to send up different equipment for that. Staging?
Roger, we have staging ignition. Roger, staging.
Yes, the booster was not powerful enough. The endurance, I don't think it had the environmental control systems powerful enough to do it, but that's up for grabs. Technically, yes, the booster, but that was the most that was going to happen with Gemini. They had like winged Gemini that would land on a runway. They had all kinds of crazy Geminis. All right, so we are running low on fuel now, and you may notice, yes, you maybe have noticed by now, yeah, the perigee is still not coming up. Yes, you've probably seen this by now, yeah? So, we're out of fuel. Perigee is still 0, right? So what we do...
Roger, Seco.
What we do is that. And immediately, we finish the insertion on ohms. As circular as you can get it. All right. There we go. Now, check this out. Look at this. Yeah, seeing the lights, talk about flying through the lights. Huh? Imagine an EVA with this, right? And this is where I'm going to send that screenshot to him later. Yeah, it gets crazier. Check this out, right? Check this out. Because it gets crazy. I also realized I forgot to do the insertion checks, so real quick, let's just quickly just run through that as fast as we can. Okay, well, yeah, the insertion checks were easy. All right, I basically did them. Cool, 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 cool. Go to pulse, orbit rate, red, retract. Only reason I'm doing this, you guys already know that I don't like using these, but the only reason I'm doing it is for the interest of time, because time is of the essence. Chord, continuous, camera seek, down, and ohms. Stuff is off, yep. And vent the cabin. All right, cabin's vented. Let's just cruise along to the next light chain. Oh, it's in the daytime. No. All right, around again. All right, green light's pretty cool, but meh. Purple lights. Now this right here is what it's all about. Toggle the hatch. Let's do EVA. And look at that. Would you look at that? I think that's worthy of a photo. But wait, it gets even crazier. Watch this. We are inside the Aurora Australis. Inside the Aurora Australis right now. I mean, he is gonna go absolutely hog wild seeing this. For sure. This is what I keep trying to get him to do. And damn the lighting. It's so glitchy. That docking light has got to get some serious rework. Meow, 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 meow. All right. With that, I think I'm going to end it here for dinner. I'm going to cut up some bread, cut up some of that that raw bacon that's been smoked a really long time. You know what I mean? The smoked salami and a little bit of onion, a little bit of cheese, a little bit of pickle, couple cranks of salt, couple cranks of pepper, and that is dinner where I'm from. Yes, we call this Speckbrot. That's dinner where I'm from. So I'll see you all next time, and thanks for sticking at the end, even though it has nothing to do with the Apollo 11. I just really wanted to show this off. So thank you guys for coming by. Unfortunately, I won't be on for, well, I'm just not going to be on until a really, really long time from now. I would say probably another week or two. So I'll see you guys when I'm available next. Until then, have fun with Rebels streams. And I'll be popping in to check on him as well every once in a while when I can, but
I've gotta take that flight back to school, so that is coming up soon. So unfortunate, but yeah, we all got to get an education. So no, it's not. It's not modeled at all. Reentry is only Gemini 8. So every mission you fly, even if you could fly it however you want, but there's always going to be the Agena. It also, you can replace the Agena with another Gemini, but all the time when you just load the basic stuff, it's Gemini 8. So. Yeah, stay safe out there. Tell me about it. I'm looking at the fucking crime rates in the US. It's ridiculous. Where I'm from, the most crazy thing that happened ever was that that one incident recently. But that's it. Like, there is no crime here, so it's ridiculous in the US. And it's not even the guns, it's just the people. It's bad people. But yeah, thank you for stopping by, Istvan. Yeah, maybe when I'm in the US, I'll go back to the gun range and do some shooting. That was really fun. I did enjoy the gun range. But yeah, I'll see you all some other time then. Get you all in the future when I do that Apollo 11 moon landing, and then all those lunar module tutorials have really got to come out. We did a little bit of the LEM today without a tutorial covering it, just because it was just basic switches and stuff. But that LEM power up is coming, the landing, that P-52 in the LEM. It's all gonna be crazy. So stand by for that in about probably a week and a half, 2 weeks. So yeah, thank you all for stopping by, and I really appreciate the amount of time that you guys have spent in stream today. When I can, I'll try and put up. I know that some people really liked my quiz posts about the spacecraft backup systems and stuff. Maybe I'll try and push out a few more of those. So to bridge the gap, but I already know that YouTube is going to stop promoting my videos, and I'm very sad for that because my subscriber count is going up every day. But life is life, so it's probably going to do a little bit of sabotaging, yeah. So, but don't worry, I'll get everything back in order, and we'll be up and going for 2.5, 3 months. For during school, I'll have lots of time to stream, most likely. When my husband's at work and I'm in the U.S. and the 7-hour difference and all of that. So it's gonna be good. Now I am graduating, so I do have capstones and stuff to worry about. So, midterms, finals, and even more intensely so. But I think I can squeeze in a few streams every now and then. So we'll get the algorithm gods back on our side, but it'll take some time. So yeah, I really appreciate it. Thank you guys for stopping by.